Hi, sorry, I was muted. So thank you. Let's start. So right now, Jing, Sad, and I are working on a blog post for snapshot feature. So this feature will be available for version 1.12, and we'll continue to add all kinds of documentation in Kubernetes, in CSI. I'll put the list later. I think last time we discussed some documentation for user, like more focus on user side, and some documentation will more like for developer. So we'll address all of those. And today's meeting, I want to more focus on a list of the next step, the features we want to have for snapshot after we have all those basic building blocks. And so right now I have a list. Welcome to give us feedback and add more new things. The first one, I think we discussed a little bit in last meeting related to finalizer for protection. So there are a few scenarios we might need some kind of protection. The first is, for example, you want to delete a volume, but currently it is trying to take a snapshot. Or actually you want to delete a volume when it already have snapshot taken for this volume, because some storage plugins will not allow you to delete the volume if they have snapshots associated with it. And also some volume plugin might have incremental snapshots, so you cannot delete a snapshot if there are some other snapshots associated with it. And the last time we kind of agree that in this scenario, we don't really need some finalizer to protect. So the controller will issue the delete request, but the driver will give us the give us response whether it can delete the volume or snapshot in this case. And if it does not allow to delete volume or snapshots, and it will give us some error message. And so this error message will be popped up to the controller and will show in the events in our objects. And the controller will keep trying to delete until it is possible to delete.
Won't that result in inconsistency across different implementations?
You mean in some, it's not implementation, it's mainly for
right, but I mean, if I have two different Kubernetes clusters and I try the same action on both clusters, I could get different results because there's a different storage plugin being used across those two clusters.
Right.
Is that seems undesirable to me.
Undesirable? You mean undesirable?
Undesirable, yes. It seems like we should be designing for consistent behavior, and if the backends have their own idiosyncrasies, it should be pushed down to the backend to deal with.
So yes, we push down to the backends to deal with it, right? So we just issue the request, and the backend give us respond, whatever response given by the backends, and we just show it to user.
Well, the alternative that I had in mind was you could require that the backend reports success even if it didn't actually delete it, and then it's incumbent on the backend to figure out how to delete it when it can be deleted. So it's no longer Kubernetes' problem to worry about this thing. As far as Kubernetes is concerned, it really is gone.
But,
that would be the alternative. That has its own set of problems.
Right.
But that would be a more consistent user experience, and would have some advantages.
So it's quite, let's say, similar to like, I think, delete volume, right? So currently, if you try to delete volume and the backend does not allow you to delete volume because the volume in use, so the Kubernetes just report, okay, kind of some failure, right? The object will still be there. So it just has a deletion timestamp there, but it's not really deleted successfully yet. So it won't actually delete the object at that moment.
Right, but if we had like conformance tests, those kinds of implementations could never pass these conformance tests because the conformance test is going to set up a known configuration and try a known sequence of steps and expect everything to go as you know as expected. And if a backend can't delete a snapshot or a volume for whatever reason, it would fail the conformance test. Even if eventually retrying would succeed, that's still not good enough. You know,
So, but I feel there will be cause quite some issues if the actual physical snapshot not deleted yet, but we just report it's deleted successfully.
Well, so speaking for NetApp, but we at NetApp have had to deal with these kinds of cases. In fact, we have exactly the situation where we cannot delete an actual volume that has a snapshot if the snapshot needs to stay around because our implementation has the snapshot being a member of the volume. But it's not unrealistic for us to lie and say, yeah, we deleted that volume, and for us to basically keep track somewhere that when the last snapshot is gone, we need to delete the volume. We'll leave ourselves a breadcrumb to go do that work later. We've had to do that for other systems. It's irritating. It's more work for us, but it produces a more consistent result externally. So it's worth considering that
I see.
as the semantic that you're expected to succeed on the delete, and then it's not Kubernetes' problem anymore. It's now your problem to actually make the delete happen when it's possible.
So then you mean for delete operation, CSI driver always responds like delete succeed, no matter what.
If it can acknowledge that the deletion is intended, and it can do whatever work it needs to do to ensure that it will eventually be deleted, then it should return success and say, yeah, I'll delete that when I'm able to. You don't need to worry about it anymore.
Okay, then we need to kind of make it very clear between the driver and the controller, right? So currently, in the CSI spec, I don't think we have that kind of information for this particular case.
Well, I mean, we need to, I think, make it. It sounds like the decision hasn't been made, and I'm not saying it has to go this particular way. I'm just pointing out that there's a choice to be made here. We can either surface up the ugliness to the end user that sometimes snapshots can't be deleted or sometimes volumes can't be deleted, or we can say no, we want to provide a consistent experience and force the developers to deal with the ugliness on their side. And both options have issues.
Hey, so Ben, right now we don't really have any restrictions right now, right? So basically it's really left to the backend. I think it's hard for CO to add this restriction.
We have like
because
the CSI sanity tests, which are a de facto conformance suite, and I would expect that we would add a bunch of snapshot tests that would test these kinds of things, like can I create a volume and then create a snapshot and then delete the volume, and the conformance test will expect that to succeed because that's a reasonable expectation. But if a backend fails, then what? It's a
Yeah, so currently for, let's say, for volume part, although we don't have snapshot feature, but the underlying, let's say, system might create snapshots already. And we only test for volume currently. And so we don't really have any restriction or anything, let's say, it just depends on the backend of whatever message response you have, and when you delete the volumes, it's also possible, like without Kubernetes, right? You can create snapshots for volume already, and the current behavior for volume, right? At least it is, it might return some error if the backend currently cannot delete volume.
So I have 2 comments. I agree with Ben that we shouldn't expose the ugliness to users. Users don't have to be aware of how this backend works or how that backend works. I think the better alternative to what Ben suggested, which was lying about successful deletion, things like that. I think the better alternative would be to use backends that have a coupling between snapshots and the corresponding volumes. They can decouple their life cycles. So for example, like the NetApp backend that Ben mentioned, they can promote a snapshot to a volume, and that way that snapshot has an independent life cycle from the volume that it corresponds to. And later on, when you want to create a volume from the snapshot, effectively you're cloning that volume. So yes, you would lose some storage efficiencies because now you're more space and stuff like that. But as far as the user is concerned, as far as the CO is concerned, all those complexities are managed by the plugin. And I think that's a better route than basically my suggestion is to leave it to the plugin and however plugins want to tackle this problem.
But is it acceptable to just say, no, I can't do it and call that a well-implemented plugin?
So I don't see any problem with returning an error, and it's up to the CO to retry. Yes, so we already do that for provisioning. So let's say if you fail in provisioning a volume, you keep retrying until you succeed. So
but then how do you write a conformance test that checks for correct behavior? If the correct behavior is I'm allowed to return an error as many times as I want.
Well, this is already happening with provisioning today, like dynamic provisioning. If you can't provision on the first try, you keep retrying until you succeed.
The test, since we designed the test, we could, let's say, design the way we first delete snapshots and then delete volume. So
yeah, but if the semantic is supposed to be that you're allowed to delete the volume before you delete the snapshot, then we need a test to validate that that is something that you can do. Otherwise...
Wait, why do we have to enforce this? So let's imagine there is a backend that won't allow you to delete a volume unless all the snapshots are deleted. If that's the case and you go and delete the PVC, that process should basically fail hanging saying, I am unable to delete this volume because the snapshots need to be deleted first. The status has an error, the user comes along and reads it, and then they're responsible for doing the cleanup.
Exactly, yeah, I agree.
So yeah, I think the test, we don't need to make it for all plugins, right?
I mean, we can do that, but I consider that basically exposing the ugliness of the implementation all the way through to the end user, which has its own downsides.
So I think this information may be also useful for users, so user understand, okay, your volume still have snapshots somewhere. Otherwise, it just tells user, and so user can go ahead, okay, first delete snapshots and then delete volumes. So we can hide this information to users. So user know.
Right, this is just like, for example, whenever we create a pod, the pod wouldn't start unless all the dependencies for the pod, which are let's say the volumes, the PVCs are, have corresponding PVs, and so then the pod starts. This is a similar type of dependency. You wouldn't delete a volume until you delete all the corresponding snapshots. So it's just a dependence that users have to be aware of, so they can address it.
But there are certain scenarios which you should be able to set up and execute like a script of actions which would be expected to exceed on any plugin, right? And those are the kinds of things that you would put into a conformance test, and you say, look, no matter what your requirements are, your dependencies are, it should be possible for this sequence of actions to succeed on your plugin. And then you design the conformance test to run those actions, and it's up to the person running them to ensure that the prerequisites are met, and then you do it and it passes, and you say, great, you conform. And we're setting up a situation here where it's just not possible to write that test.
Well,
because
not that. Why would we not want a plugin to conform to this behavior? I guess is my question. I think I'm missing that point. Why wouldn't all plugins want to have that deleted before they delete the volume? Is there a case where that's, a requirement on plugin?
Backend have different capabilities, or some backend can support that, some backend cannot.
Yeah, and on the CSI side, we've used, or the Kubernetes side, we've decoupled the life cycle of the snapshot and the volume so that they're not related as far as Kubernetes is concerned. It should be legal to delete one without deleting the other. So Kubernetes doesn't know that there's any dependency.
So yeah, my point was that backends, that want to support the way Kubernetes treats snapshots and volumes, they can emulate that by promoting a snapshot to a volume and manage the snapshot lifecycle the way they manage a volume. That way they're decoupled. So it's up to the plugin implementers to figure out the best way they can make this happen with Kubernetes.
But it sounds like it's also up to the plugin implementers to just expose their ugliness and not do anything nice if they want to. And
they are not exposing their ugliness because because they're treating snapshots just like first-class volumes. So the decoupling between a snapshot and a volume goes away.
But the question is, are you allowed to fail or not? Like, yes, you have the option to make your plugin smart enough to not fail, but other people might not make that choice. They might say, "Oh, well, I'll just be lazy and let that operation fail, and the user can deal with the mess on
and
their
that's
own."
okay. Like, that's an option that a storage vendor gets to make, right? They can do extra work to make a nicer user experience, or they can let the error bubble up to the user and let the user handle it. I think I agree with Ben's original point, which is by trying to work around this at the Kubernetes layer, we introduce inconsistencies in the behavior of the Kubernetes API, and that's pretty bad. So I would prefer to leave this to the storage vendor to decide. They can choose to handle this at their layer and make it pretty, or they can surface it up to the end user. Either of those is okay. I don't think we need to have a conformance suite around this to say you must do this behavior or not. Leave it up to the storage vendor.
Yes, I agree.
At least for now.
Yeah, I think I agree with that. And there is some trade-off, right? So if we hide the arrows at that moment, it's not deleted yet. When we say it's deleted, it will cause some issues, definitely. If the system never be able to delete it and the user just have no knowledge about that. And so I think the plugin can do some smart things and try something, but it need to delete the snapshots and then return it successfully deleted. We can also,
or it just surfaces the error and says, sorry, in order to delete this volume, you first need to delete the snapshots, which means the users are responsible for the cleanup. And it's not the end of the world because you're not putting the user in a position that they cannot recover from. They would just need to go in and delete the snapshots first. But that's a decision you leave up to the storage vendor.
So for the test, I think we can just design. Basically, we create snapshot and delete snapshot first, and then delete volume in that sequence. This will have any issues for that?
I don't know. I think you should have both tests so that you can test deletion of the volume before the snapshot. But if that's not expected to succeed always, then maybe that test needs to be marked optional or skippable or whatever.
Yeah, that could be optional to certain plugins. So if we know already which one can support.
So to be clear, I don't think we don't really have a CSI conformance suite at the moment. We have the CSI unit test suite, which doesn't really test behavior across methods, just for individual methods.
Or are you talking about CSI Sanity?
Yeah.
CSI Sanity does test. It has some pretty complicated stuff in there.
Ah, okay. I guess I haven't kept track of it.
And I've been trying to add more stuff, and I would love to add these kinds of complicated snapshot tests that we're talking about to it.
So my understanding is that the CSI sanity tests are essentially run as unit tests, so the driver doesn't expect the backend to actually exist. Is that true?
You can run it. I mean, there's a mock backend that you can run it with, but you can run it with real backends, and it actually exercises the real backend.
Oh, beautiful. Okay, I need to.
And it's a great start of a conformance suite.
Yeah. That's what I was going to say next, is that we do need something along the lines of what we're talking about here, but it sounds like CSI Sanity is already there, so I'll take a look at that.
Yeah, but I think those tests has to be in sync with what is defined in the CSS spec, right? We don't want to add extra things that are not written in the spec.
Yep.
Yeah, and I've been filing bugs and fixing those bugs as I find them, because it was testing things that were not in the spec, and it's not testing things that are in the spec. And of course, it's very hard to get it 100% together, but as we find divergences, we should fix them.
Yeah, yes. I think we are also working on that for snapshots too. So I think
each version of CSI spec should have its own test suite.
Ideally, yes.
So I think for this kind of case, we kind of agree, at least for now, right? We depend on the plugins to give us whatever response when you try to delete something, right? The delete operation will like return from CSI based on the CSI response. And another scenario is more like when you, for example, trying to delete a snapshot, but the snapshot currently in use. In use means someone like is trying to create volume from the snapshots. I know for some backends, it will not allow you to delete snapshots. It will return error like something like the resource in use. But I'm not sure this is consistent across all the backend plugins. So it's possible we can, in this case, protect at Kubernetes layer at the finalizer, because it is more like a snapshot in use, and we can monitor that. And then we prevent users to delete the snapshots while it is in use.
So I'm sorry, what is it that makes the snapshot in use?
Means there is a operation going on, which is create volume from snapshots.
Okay, so and then once the volume is finished creating, it's not in use anymore.
Right.
And then you can delete it. Yeah, that makes sense.
So then we can add a finalizer similar to PVPDC finalizer. So when I say the volume is attached, we don't allow you to delete the volume until volume is detached. So similarly, we can have some protection for this in use case. And another scenario is volume in use, which means you are trying to create snapshots based on the volume, from the volume. And at the same time, you are trying to delete the volume. So if you have a protection, you will prevent volume being deleted while it is still taking snapshot. And then after snapshot is taken, and the volume also, let's say, make sure it is detached.
And where does the state machine live that determines whether it's in use or not?
Currently, the finalizer code for volume is in the PV controller. So then I think it's makes sense to add some similar logic in the snapshot controller. So snapshot controller can know, basically it's based on the finalizer, right? When you create volume from snapshot, when you issue this operation, you can add a finalizer to the snapshots.
So the state machine is in the Kubernetes API, not in the plugin.
Yeah, it is not in plugin. Yeah.
So Kubernetes is going to have some flag that says this volume is being used by a snapshot, or this snapshot is being used by a volume.
Right.
And then something has to clear that flag when it's done.
Right. This is how finalizer currently working. So otherwise, we can depend on plugin also return some error. So I'm not sure all plugin support this or like give us consistent behavior or not. So for example, when snapshot currently you have another operation like create volume from snapshot, and you're trying to delete snapshot, what
I think Kubernetes should keep track of outstanding snapshot operations, not plugin. So Kubernetes should know whether there is a snapshot operation in progress. And
right. Like I said, some plugin can have some kind of mechanism, right, to prevent you doing this, but I'm not sure whether it is true for all plugins. So when I say
my point is,
we can do
Kubernetes should rely on the plugin. Kubernetes should rely on the state it manages itself to keep track of all the outstanding snapshot operations.
And not only that, but there needs to be a way to get out of a stuck state if something is marked as in use erroneously.
Right.
You need to be able to get it out of that state so that you can really delete it.
Yeah, that's the kind of side effect. If there's some bug, or let's say you didn't consider all the scenario corner cases carefully, it's very possible that you have a situation or you never be able to delete something. So in order to do this, we need to make sure we consider all the corner cases and to prevent that happen. So yes, this is kind of a trade-off. So we add this nice feature like to prevent you something bad happen, but also we might cause something like undesired. So if we all agree that's a nice feature to have, then.
Sorry, could you describe the feature again that you're proposing to fix this?
So basically we have a finalizer similar to volume finalizer, right? So whenever you detect you have an ongoing operation, let's say you create volume from snapshots, and you put a finalizer in the snapshot object, indicating it is currently in use. And until
okay, got it. Cool.
The creation finished, you remove that finalizer, and if you want to delete snapshot, you can. Otherwise, there is finalizer in the snapshot API object. You cannot delete snapshots.
Yeah, that seems reasonable to me. And I agree with Ardalan and Ben too. In addition to this, we should also make sure that the controller that does the operations also keeps track of what operations are pending and doesn't issue multiple operations on the same snapshot or volume that needs to be.
Right.
Yes. But it occurs to me that this is exactly the same situation as what we were discussing in the first part of the meeting, which is, you could just let the plugin fail, and then it's up to the plugin to figure out what if it can do something smart or not, and to not track any state at the Kubernetes level and say, if you can't delete the snapshot because it's in use, just fail and we'll retry it. Similarly with deleting a volume that's in use. I think
retries are always retried, right? Or sorry, deletes are always retried, correct?
Yes.
Okay, so then why do we, to Ben's point, why do we need to add additional logic here? Why not just let the plugin say, sorry, I can't delete this right now, it's in use, and then we retry with exponential backoff?
So it's possible. It's just, I'm not sure whether all the plugins, they have some protection, more like if you are trying to delete snapshot while it is still using snapshot to create volume, it might cause some data corruption, similar like you delete volume while it is still attached. I'm not sure. So it's just
it seems like that would be a bug in the plugin if it's not smart enough to prevent data corruption, right?
So
why should that be Kubernetes' problem if the plugin can't figure that out?
Then I'm not sure for delete volume while it is still attached, whether the plugin should also be able to detect that and prevent you to delete volume.
Well, an attached volume is something that Kubernetes has to know about because it manages the pod and it manages the attachment, but the relationship between a volume and a snapshot is not something Kubernetes manages. So you could make it out of scope and just say, hey, do the right thing, otherwise users will suffer.
Yeah.
Which it sounds like is what we're saying about the first case of the ability to delete a snapshot or a volume that has snapshots. We're just pushing back on the plugin and saying do the right
I
thing.
think the difference that I see between the first case and this case is that the workaround on the Kubernetes side in the first case would result in weird, inconsistent behavior, whereas the proposal here actually will just give us added protection without any weird behavior. So over here we can add protection. It'll make it a nicer experience, and we don't really have any negative side effects here that I can see.
Okay, I buy that. But how about just the added complexity and added work of doing it? It doesn't worry.
Yeah, I mean, I would rank this a P2 in terms of functionality. Like, I think what we need to do, and I believe Xing and Jing are planning to do this, is come up with a list of features to move this, or a list of tasks to move this feature to beta. When they do that, I would imagine this would be a P2.
Right. So it's not.
I think the main difference between this problem and the first problem is that this would benefit all plugins, all volume plugins, whereas the first one would only benefit the plugins that had the limitation for coupling between snapshots and volumes. So if it makes sense, so if it makes sense, for all plugins, we might as well do it in Kubernetes.
Yes. So the second one should apply for all plugins. Yes. Yeah, I agree. Like, it's not like a must-have, right? It's a nice feature to have, and we can see when we should do that. It definitely adds some complexity in the system. So consider trade-off. We can make it more like a P2, and we can work on whenever we think it's a good time. Yeah. And so can we move on to the next one? And so the second one on the list is the retry policy. So right now, Snapshot is kind of unique because we say we only create snapshots once. And in case of failure, we just report the error, and the current controller won't retry because snapshot is kind of time sensitive. And when users say, okay, create now, they might not want to like retry in a much later time. Just let the controller to keep retrying.
Yeah, I like the existing behavior. It makes sense to me.
Yeah.
I actually encountered this during my testing because I created a PVC and then created a snapshot before the PV even created, and it failed for obvious reasons. And I was like, oh, what happened? And then I realized what happened, and I was like, oh, that makes perfect sense. You can't take a snapshot before the data exists.
Right.
So, and you wouldn't want it to retry after the data exists because that would be weird.
But we're thinking for some users, they might just allow you to like retry a little bit. So let's say retry for a minute or retry for a few seconds. Otherwise, it's just once and then done. And
I'm not sure it's a reasonable feature because when you take a snapshot, you want it now, and there are other higher level of snapshot policies scheduling that will help you to snapshots on a specific time. So I'm not sure if it could lead for a snapshot that are not in the right time that the user meant to.
Yeah, I think that's an important point.
I'm not sure if it's needed at all.
I think it's an important point that snapshots are very much time bound. When you expect to take a snapshot, you expect to take it within a certain time frame, which is why the retry, not having a retry makes perfect sense, like Ben said. But if there is some room for retry, we should enable that scenario. So what I was imagining was having instead of saying, oh, please retry for 1 or 2 minutes, what you say is, please retry up to a given timestamp. So, we QS a workload, for example, and we know that we have 30 seconds to take that snapshot. And so what we can do is pass that information to say, hey, for the next 29 seconds, please try to take the snapshot. And so if it takes a snapshot within 5 seconds and fails, it knows that before that timestamp, it can continue to retry. But after that timestamp, it has to give up. I think that would be potentially useful.
Yeah, I like that, a deadline, a snapshot deadline. And in theory, if the system is slow enough, you could fail the deadline even before the first try. And to say,
Right.
hey, I didn't get around to taking the snapshot by the time you asked, sorry.
Sure. So you mean the deadline is like a time, is not a period.
Exactly. Don't do period, because periods can, at 2 minutes from now, we don't know, like that. That's harder to predict. Just say, here's a specific time that you have. If it's before this, you have a chance to retry. If it's after this, we're going to assume you're failed.
Sure. But a different machine, will it have some time differences in their like?
Yeah, we need to think through that as we design this thing.
Because
by the way, I'm not familiar with any storage systems that actually do retry after snapshots fail. So again, maybe the use case you mentioned makes sense, but definitely the default behavior should be 0.
Well, I like the idea of a deadline, not for the retry case, but for the system is so slow that it couldn't even make the first try by the time, because there are systems where it matters that it took a long time.
If it couldn't take it on the specific time, it's useless. So this storage system cannot take it on the right time. So it's not good to take it a few seconds after, because it's not the data you wanted. You wanted it in a specific point in time. Snapshot is point in time.
So if it matters that much, you set the deadline to like 1 second from now. And
so it's just optional. So if you don't specify, then it won't retry. So here it just allow you to have this retry, let's say deadline or.
Well, that's not obvious. I mean, you could define no deadline to mean retry forever. So it's up to the implementation of how you interpret no deadline. But I think it's clear what the interpretation of having a deadline should be.
Right.
Yeah, retrying up to the deadline does make sense.
Yeah, because for creation, it might like fail at different places, not just plugin cannot. Maybe there's some, let's say, API server temporarily cannot reach, or some other kind of problems when you try to create. So you might want to try immediately again and see whether it can pass through.
Well, but that case you're talking about, if something is slow or something's unreachable, the retry needs to bubble all the way up to whatever is invoking the snapshot typically, because usually there's something else going on. You're talking to the application that's managing the data. It's in a quiet state while you're taking the snapshot, and if you can't get the snapshot taken by some timeout, you're going to unquiesce the application because it needs to keep doing work, and you'll come back and you'll try the whole process later on. So that the retry needs to be above Kubernetes head in those cases.
Yeah, I think so. Each time when we try to create snapshots, if there's a problem, we will like definitely show it in the, let's say, events or some conditions. And so if you have a deadline, controller within the deadline time, it can issue another, like a few other tries. The application normally will quiesce the application for a certain period of time, and then so it's allow user to specify the retry period, like retry deadline, and within that period of time when you quiesce the application.
So I would support the idea of a deadline, but you're going to have to solve the problem that Saab mentioned of how do you specify, what time zone is that in? How do you deal with clock skew, time drift, all the other problems you can have? Plus, you still have to define, if the deadline is not specified, does that mean retry forever, or does that mean retry 0 times?
For my initial thought is if you don't have a retry policy, but it will default not to retry. So this is our current default behavior, not retry, no retry. Only if you specify some kind of retry policy, then we can have retry.
So it's like one shot, take it or leave it.
Yeah, that's the current behavior.
And it might take 5 minutes or it might take 2 seconds. You don't know.
Yeah, I think this idea is worth exploring. I would put it as a design project for beta. We can think through what the design looks like. Does it make sense with skew and time zones and all that kind of fun stuff? And see if it makes sense. And then also at the same time, see if there's actually a concrete need for this. Are we seeing failures that would, had they been retried, result in a successful creation of a snapshot? Once we have more data, I think we can make a better decision on this.
Sure. Yeah, I think you mentioned like if you have deadline, then when creation kind of more like timings and take very long time. But in CSS spec, we do have a timeout, so it should return within, let's say, 1 minute or 2 minutes. So it's currently, I think, maximum time, let's say a few minutes, and then it will time out.
But for some applications, that's not fast enough. Some people are going to say, no, I really need it in 10 seconds or less. Otherwise, I'll try again later.
Okay, right now we don't have a cancellation, right? You cannot cancel operation. Then, but it's possible we can change, like make it configurable for like CSS spec to return response within certain period of time. We can change that. It's possible.
I mean, you don't have to deal with that case. The applications that have that requirement could just observe the snapshot after it's taken and realize it was taken too late and just delete it and try again. But yeah, you might waste some work there.
Yeah, right. User can manually delete it. Then we will try to delete it. And so this is for creation retry policy.
The issue is not really realizing it's got too late. The issue is that once the application resumes, it will touch the data, and then you have inconsistent snapshots potentially. That's the main issue.
Well, right. And so under the current design, if the API timeout for CSI is like 2 minutes, the snapshot may eventually get taken after you don't want it anymore, and then you'd have to go delete that snapshot, which is fine. Because the snapshot would have inconsistent data, it's not worth anything.
Yeah, the snapshot will give you the creation timestamp, so you can check that. User can check that and see whether it is the one you want. Yeah. So another is more like policy related. Is currently we only support on-demand snapshot, and some user might want to have automatic snapshotting, like periodically snapshot. But this, I think, also could be like next a higher level of controller doing that. The simplest way, let's say you create a script, and then you just be able to create snapshot periodically based on some like period, or you can set a time. Like
well,
every day.
So you can do that, but I'll raise the issue that I raised a while ago because this is an important issue to me. The main problem I have with doing those kinds of things through like a higher level controller is Kubernetes will eventually know about a ridiculously large number of snapshots in that scenario where if you say I'm going to take snapshots every hour and I'm going to retain them for a week, and then I'm going to have another retention policy past a week, you can end up with hundreds of snapshots for every one of your volumes, and most of them you're never going to care about, but Kubernetes will have to track all of them, and you'll end up accumulating thousands or tens of thousands of objects in the Kubernetes database that nobody ever wants to see, except for that 1% case where you're like, oh, I need to do a restore. And that's a pretty big tax to put on the system.
So
yeah, but by the way, it could also have value for having all this information inside Kubernetes, because for the Kubernetes admin, it's really important, and it will be easier for him to restore in any point in time. So I agree, it may lead for too many objects in the system, but I think maybe Kubernetes can hold that, or it could be, you cannot prevent anyone else to develop such a controller that and I'm sure
Oh yeah. I mean, no matter what we do, there will be people that will just write a cron job that takes
something
snapshots.
very basic, and everyone need that. So anyway, you will get to a point when the customer at the end of the day will go some sort of snapshot scheduler in Kubernetes and cause a lot of snapshots.
So one thing might help is the one I list below, is we give the functionality. Let's say user can easily list all the snapshots taken for a volume like PVC. So basically, user can query, okay, for this volume, what snapshots associated with this volume, and also to delete all the snapshots associated with this volume. If we have this kind of functionality, then the upper level like controller can, I think, easily to kind of have some policies or ways to, let's say, delete the old ones. You only keep certain number, and then it just functionality might help.
Well, so I like the idea of having snapshots that exist outside of Kubernetes knowledge up until the point when they're needed, at which point Kubernetes becomes aware of them and you can start using them. And that unburdens Kubernetes from having to track, a potentially huge number of objects. You're right. Some people will do it through Kubernetes and use, they'll create these snapshot objects and you'll end up with thousands of them. And if that's what they want, that's okay. But it doesn't seem like a good design to me. So having an alternative, which is something outside the system, is automatically taking snapshots and automatically aging them out and retaining them on some policy. And then only when you decide, oh, I need to do a restore now, there's got to be a way to take that snapshot that exists outside the system and pull it in and say, okay, now I want to use this snapshot and go create a volume from it.
But then every storage vendor will have to develop that for his
own. No. We already have the list snapshots RPC in CSI, and that is defined to return all the snapshots, whether they were created by Kubernetes or not. So there's a mechanism to get the information out of the plugin. It's just that, what do you do once you have that list? If the object isn't already there in Kubernetes, do we have a way to take it and put it in?
So you say that when
I think importing it is the easy part. The harder part is when the life cycle of that snapshot is managed by the backend, and then you have to reconcile the Kubernetes state with the backend state. This is where the problem comes in. Yeah, importing it is easy. You can just import it from the backend, but then once you create a corresponding snapshot object inside Kubernetes, and let's say the storage backend garbage collects all the snapshots that are more than a day old, then you have to somehow reconcile the Kubernetes state with the backend state, and these are where the complications come in.
Yeah.
But I agree with Ben. That this is an important use case that we should figure out, and it's somewhat also related to the previous discussion regarding the deadlines, because the way Kubernetes works is a declarative model. Eventually, you're gonna take some action, and there are no time guarantees for the eventuality of your action. So if somebody wants snapshot now, there is no guarantee by Kubernetes that it would happen within 5 seconds. Or I'm not talking about the backend part of it. I'm just talking about the all the activities that happen on the Kubernetes side. The controller may pick up some event with some delay. So if people really care about time, it may make sense to use the backend capabilities to take snapshots at exactly the right time. And that makes consuming scheduled snapshots from the backend more important for those use cases.
You mean the ability to import them, at least?
To import them, yeah. But then once you import them, then you have the problem of reconciling the Kubernetes state with the backend state.
Well, you could imagine pinning anything that gets imported so that it doesn't get deleted, and then that solves that problem. But yeah, that you would like to be able to automatically reap them and keep Kubernetes in sync with what's going on.
Yeah, so like here, when you list all the snapshots, my like initial thought is based on the objects in Kubernetes, release all the snapshots that you taken through Kubernetes and then return. It's not a full list from the backends that relate to this volume. They could be like, the list could be different, totally different. So, I mean, the list here, if you say list all the snapshots taken from this volume, like this PVC, right? Kubernetes, what Kubernetes can do is it just go through all the snapshots IK object and check which one relate to this volume, related to this PVC, and then return the list. Another way is go to the backends and list all the snapshots like taken from this volume, and the backends will tell you all the list. These two lists could be totally different.
Well, they shouldn't be totally different, but you're right that the one in the back end could be longer.
Yeah, longer, yes.
I think we'd have a problem if Kubernetes knew about some snapshots that the back end didn't know about.
Yeah.
So one should be a proper, or one should be a subset of the other.
Yes. So then which one we want to use here? I think my thought is we only care about the snapshots like managed by the Kubernetes. The snapshots like outside, taken outside.
Well, as far as the Kubernetes API is concerned, yeah, you should only care about the ones that Kubernetes knows about, because anything else is kind of ridiculous. But there has to be a way to get Kubernetes to know about these other snapshots. I think that's what Ardalan was getting at. Some sort of an import, and then a way of, I don't know how you I don't know what the right way to handle reconciling snapshots that are going to automatically get deleted is.
Yeah, I just shared an email that I sent to SIG API Machinery a while ago. So I explained these problems to them, and there was no resolution. So feel free to take a look and comment on it.
Sure. You mean if the backend deletes snapshots without involving Kubernetes, and Kubernetes doesn't know the snapshot already gone, it still has the.
So the way many of the storage systems that support scheduled snapshots work is that, for example, you specify policies to keep so many daily snapshots, so many hourly snapshots, so many weekly snapshots. So the storage system takes care of the snapshot lifecycle for you, right?
Right.
So we can define a policy that keeps around, let's say, 10 daily snapshots. And then as soon as you go to the 11th day, then your first snapshot gets deleted. And now you have, if Kubernetes has an object to keep track of these snapshots, then you have to reconcile the Kubernetes state with the storage backend state. And that's the challenge.
So I think right now we do have the controller. It might not have this all the time, but the controller will periodically check. Let's say that we have two objects, snapshot and snapshot content. And the snapshot content has the snapshot ID. And it can checking the exist of those snapshot IDs through the plugin, the backend. And
yeah, but you don't want to be polling all the time for that, because that would be obscenely expensive.
Right.
I mean, we're talking about tens of thousands of objects for even a modest size, cluster.
So you only query that specific snapshot to check if it still exists or not. If it's not exist, then we can report the error to the user. It's similar to volume, so we do have like a checking, periodically checking whether the volume is still attached or not. Although after you first attach it, and we do periodically checking.
For only attached ones, or all of them?
Only the one you want to check, not all of them. So
Okay, well, I'll just point out that it's quite likely that people will have 2 orders of magnitude more snapshots than they will have volume. So consider it like 100 times as expensive as whatever the volume monitoring mechanism is.
Okay, then it's going to be expensive operation. Yes.
If you really want to check all of them all the time, yeah.
Yes, so we can.
By the way, I want to mention something that in many cases, the scheduler of the snapshot is not inside the storage system. Many use cases are usually do it in a different system, different applications that handle the snapshot. Yeah. It's not being managed by the storage system. In many cases, some does, but some does not.
Yeah, we have to support both styles, I think. When the storage system does it, and when something else does it, and when Kubernetes does it. I think there's probably exactly 3 cases.
Yeah, exactly. This is why I want to mention that, because there are plenty of use cases here, and not all the time the storage system is the one that track on all the snapshots all the time.
Right. Hopefully, like we as Kubernetes provide a nice way for users, so at least for users, they can easily use snapshots, like to take snapshots.
Thank you for the call. I need to drop. Keep going. Bye bye.
Sure, bye. So sorry, it's kind of almost, it's already 10. But the last item is resource quota. I think is also very important. So you can check currently for storage, we have storage resource quota. You can specify.
Can we postpone this to next week? Because some of us have to go.
Okay, sure. Then we'll focus on resource quota for next meeting. And I will try to put more notes on it. Okay.
Thank you, Jing.
Thank you very much.
Thank you. Bye.